Hello, 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 hello. Good day, everyone. Welcome to another vlog video tutorial regarding integral calculus, and we are going to discuss plane areas. So now we are going to discuss sample problems involving integral calculus on plane areas. So as you can see in the figures that I have shown here, we are going to apply integral calculus here, and take note that we have two types of plane areas. One is plane area that is opening upward, and then the other one is a plane area that is opening to the right. So this one is a plane area which is opening up. So this is particularly relevant also or related in plane areas which is opening downward. Then this one is a figure for a plane area which is opening to the right. So now we are going to discuss two sample problems. So we've got two sample problems here. One problem is regarding an area bounded by the curve, which is x squared equals to negative 9y, and the line y plus 1 is equals to 0. And then problem number 2, what is the area bounded by the curve y squared is equals to x, and the line x minus 4 equals to 0. And now we are going to draw first the figures for the first problem. So we are going to solve first the first problem. The first problem states that what is the area bounded by the curve when x squared is equals to negative 9y and the line y plus 1 is equals to 0. So what we are going to do is to draw the Cartesian coordinate system. And from the Cartesian coordinate system, we can now show in the Cartesian coordinate system, we are going to indicate the curve and the line. So the curve is at x squared is equals to negative 9y, and the line is at y is equals plus 1, sorry, plus 1 is equals to 0. So these are the two conditions that we have to satisfy, and we have to draw in the figure. So before we can draw the figure, you have to take note that y plus 1 is equals to 0. So if you are going to note this, then if you will have the Cartesian coordinate system here, and let's say this is our point of origin, then we will be able to draw the line y plus 1 is equals to 0. So take note that if you are going to simplify, or if you are going to express y in terms of the constant, the value of y will be equals to negative 1. So that is if we transpose positive 1 to the other side of the equation. So then we will have here y is equals to negative 1. So if you are going to draw the figure, if you have here the point of origin in the Cartesian coordinate system, remember that all that is above the point of origin would have positive sign. So that is for our sign convention. And then all those which are below the point of origin will have a negative sign convention. while all those which have value on the right side would have positive value, and then all those which are on the left side will be negative value. So from the point of origin, if we are going to draw the figure representing, the line y is equals to -1, then that means this value of y will be equals to a value of 1. So that means we have the line here. If you are going to draw and express the line here, this will be y plus 1 is equals to 0, or simply put, y is equals to -1. And then from x squared, take note that you have x squared is equals to -9y. And take note that if you would want to determine the value of x in terms of y, all we have to do is to substitute in this equation x squared is equals to -9y, the value of y which is equals to -1. So if we have to substitute, if we substitute y is equals to -1 to this equation, then we will have x squared is equals to -9. You multiply it by -1. So this would give us x squared is equals to -9 times -1. That will be positive 9. Then if you are going to determine the value of x, you simply get the square root, of x squared. Square root is equals to the square root of 9. So square root of x squared is x, and square root of 9 is 3. So that means from the formula of area, because we are going to determine the value of the area, according to the formula for the area for this kind of figure. So let me draw first the figure. Remember that the value of x can either be plus or minus 3. So because we have here a square root of 9, it could either be plus, negative, or positive 3. So from here, we are going to draw the figure here. Let's say this is 3 value, and then we have of course another value of 3 here. Then we can draw the figure of this plane area. So if you are going to determine the plane areas, all we have to do is to substitute the value of x and y in the formula for the area. So we are going to make use of a given area from the equation 2/3 base times height. So this is a derived formula already. So what we have to do here is to determine the area of the plane area here, the area of the curve, bounded by the curve, the area bounded by the curve, and all you have to do is to make use of the formula area is equals to 2/3 BH. So what we have to use here, 2/3 BH times area, wherein the value of B is equals to the base, which is x, and then the value for h is equals to the height, which is y. And take note that If you are going to make use of that in the determination of the area, then therefore the area will be equals to 2/3. And take note that the base here from the point of origin, this is 3 meters, 3 units, and this is also 3 units, while this one is 1 unit. Okay, so the height is 1 unit. Okay, so that is the height. So the base will be equal to 6 and the height will be equals to 1. And that would give us, therefore, the value for the area, which is equals to 4 square units. And this will be our answer. So the answer is 4 square units. So you have the area is equals to 2/3 times base times height, and the value is 4 square units. Now let's go to the second problem. The second problem states that we have to determine the area bounded by the curve, which is given by the equation y squared is equals to x. And of course, the line x minus 4 is equals to 0. So you would notice that if you are going to express x in terms of y, we can first express x in terms of the constant by simply transposing this -4 to the other side of the equation, and that would give us the value for x is equals to 4. So meaning, if we have here from the Cartesian coordinate system, the point of origin is 0, we are going to count 4 units from 0, and that will be the value for x. And take note that because we have y squared is equals to x here, this will be a diagram that would be opening to the right. So we have squared, y squared, so that means it could be in the positive or in the negative side of the Cartesian coordinate system. So take note that since x is equals to 4, y squared is equals to x, we can substitute the value of x to this equation. So we will have y squared is equals to 4. And if you are going to determine square root of y squared, square is equals to the square root of 4. So therefore, y will be equals to plus or minus 2. So therefore, if you are going to draw the figure from the point of origin, we can count a unit of 2 below or above it. So if we are going to draw the figure, by the way, the figure is not as accurate as possible. I'm not using scale here, but this is somewhat what similar to the figure that we can draw given the condition for the plane areas here. Okay. So that means either positive or negative 2. So this is 2 units and this is also 2 units. So again, we are going to apply the formula for the area, which is equals to 2/3 base times height. Wherein again, our value for B this time will be this base. And this base is equals to, sorry, this base will be equal to, okay, let me correct that. this should be 4 and this should be 4, while this one is should be 2. This should be 2 and this should be 4 and this is 4. So the value for, again, let me correct that. We have here the value of x is equals to 4. So that means this is 4 units. And then the value for y, it could be positive 2 or negative 2. So that means the value for b here will be equals to 4. And then the value for, sorry, 4 because we have 2 plus 2. And then the value of h here will be equals to 4 because x is equals to 4. So that means area will be equals to 2/3 times 4 times 4. So area is equals to 16 over 332 all over 3 unit is square units. Again, let me clarify what I did here because the value of x here is equals to 4. So from the point of origin, going to the right, we have the value of x is equals to 4. And then we substituted this value of 4 to this equation, y squared is equals to x. You have y squared is equals to 4. So we can express in terms of y will be plus or minus 2. So that means you can have here the curve drawn at 2 meters, 2 units, I mean, 2 units above x or and 2 units below x. So that means the value of base here is 2 plus 2. So that's why you have 4. And then the value of h here is 4. So that if you are going to use that, we have the area is equals to 2/3 4 times 4 or 3 halves over 3 square units. And this will be our answer to the question in problem number 2. What is the area bounded by y squared is equals to x and line x minus 4 equals to 0. So that would be all for today. Thank you very much for watching my video. Again, I shall see you on my next vlog. Good day, everyone. God bless and keep safe.